Hello students, today in chemistry we discuss about solubility. We have already discussed about solution, different types of solution, concentration units, molarity, normality, molality. Today we discuss about solubility. We want to dissolve solute in solvent. Then which factors are involved and what is the saturated solution, that we will discuss. So solubility means maximum amount of solute can be dissolved in 1 liter of solution, in 1 liter of solvent at constant temperature and pressure. Again I revise, solubility of the substance is its maximum amount that can be dissolved in specific amount of solvent. So you take 1 liter at fixed temperature and pressure, that is solubility. As for example, solubility of solid in liquid. With two types of solubility we discuss, solubility of solid in liquid and gas in liquid. First we go to this solid in liquid. We take the example, solution is prepared by dissolving solute in solvent. So you take the water, in that you add salt or sugar. If salt and sugar is added in water, first on the spot if you add 1 or 2 gram it will dissolve. Then after you add it more, then at certain point we cannot dissolve more amount of salt or sugar. This is known as saturated solution. This is known as saturated solution. Saturated solution. So maximum amount of solute which can be dissolved in a particular solvent, that is known as solubility of that particular solute, salt or sugar. Now we discuss about organic compound. You take benzene. Benzene you add naphthalene. Benzene has a cyclic structure. In that you add naphthalene. Naphthalene means double benzene. And anthracene. Okay, then triple benzene. So organic compound you take as a solvent, then you have to use organic solvent. So you add naphthalene in benzene. First you add few grams, then it will dissolve. Then after you add more gram at particular point of temperature and pressure, amount of naphthalene you add in benzene is fixed. After that it will not dissolve. So that is known as solubility of that particular solution at fixed temperature. Again temperature increase or decrease, this solubility is changed. This solubility is again measured in mole fraction, percentage weight by weight, normality, molarity or molality. So it is nothing but amount of solute dissolved in a solvent. Okay, that is solubility. Now here H2 is a polar solvent. In that salt or sugar, polar solute can be dissolved. In water if you add this organic compound, then solubility is very less. You cannot add it. Okay, its solubility it takes 1 or 2 days to solute. Similarly in benzene you add sugar or salt. There also its solubility is very less. So like dissolved likes, organic compound dissolved in organic solvent and inorganic compound is dissolved in inorganic solvent. Okay, polar then polar and non-polar then non-polar. So depending upon solubility. Another two factor which affects this solubility, that is temperature and pressure. First we discuss of temperature. Mostly you see that when temperature increases, solubility increases. But it depending upon two type of process. First one is endothermic and second one is exothermic. If you dissolve particular solute in solvent, then two type of heat exchange will take place. First is exothermic reaction and second is endothermic reaction. Exothermic and endothermic reaction. Endothermic reaction, the reaction in which if you add solute in solvent and solution is prepared, then endothermic reaction means heat goes inside endothermic reaction. Okay, in the system. From the surrounding, it enter into the solution. Then it is endothermic. Delta H means enthalpy of the solution is greater than 0. Means system gain the energy in terms of heat. So increase in temperature will increase the solubility. So for this system in which the reaction is endothermic, increase in temperature is favorable for solubility, or solubility is increasing. Second one is exothermic reaction. Exothermic reaction means certain solute if we add it in the solvent, then heat comes out of the system. That is exothermic reaction. System में से heat कम हो जाए. That is delta H of solution is less than 0. Means from the system heat is coming. So decrease in the temperature. Temperature when is less, solubility is increases. Or increase in temperature will decrease the solubility. Pressure. Pressure does not play a very important role in solubility of solid in liquid. Why? Because solid are less compressible, liquids are less compressible. It will affect in second condition, that is solubility of gas in liquid. If you want to dissolve gas in liquid, then this pressure will play important role, or solubility increase or decrease depending upon pressure. But in solution or solubility of solid in liquid, only temperature plays important role. Increase in temperature or decrease in temperature will affect the solubility of particular solution. So this is about solubility. You go through the book and try to write this as a note from your textbook, and next time we discuss about solubility of gas in liquid. Okay, very important, that is related with Henry law. Okay, Henry law. Thank you. Okay, solubility of gas in liquid. Okay, that is Henry law. Or in terms of if volatile solute is dissolved in non-volatile solvent. Gas in liquid, gas is volatile, means vaporized, and non-volatile solvent, that is liquid. So if volatile solute is dissolved in a volatile solvent, then solubility is directly proportional to partial pressure. That is, you remember Henry law. Okay, it's apply Henry law. And first one which we discussed, that is salt we added in water. Means non-volatile solute is added in volatile solvent. Then we have to apply Raoult's law. On the topic solubility of gas in liquid. Solubility of gas in liquid is directly proportional to partial pressure of gas on the surface of the liquid. What is partial pressure? If you take water in a beaker, then at particular temperature and pressure, water molecules start vaporizing. If the above container is closed, then this water molecules converted into gaseous form, and again it will apply pressure on the water surface. That pressure is known as partial pressure. Okay, that pressure is known as partial pressure. Similarly, if gas is there, we want to dissolve gas in water, then its dissolution is very less. As for example, oxygen in water, okay, solubility is very less. So we have to apply pressure, just like our heart. Okay, apply pressure to the gas, oxygen gas, so that gas will dissolve in our blood. Okay, high pressure and low pressure. So during high pressure, gas dissolve it, and during low pressure, expansion of heart, CO2 comes out from the blood. Similarly, here also, if pressure is applied, then dissolution will be more, or solubility will be more. Weight 1, suppose I apply pressure W1, then that gas starts to dissolve in particular water solution or solvent. So I have put the few dots. So less amount of gas is dissolved. If I increase the weight W1 and W2, the gas will be compressed and high pressure will be there, and more amount of gas, okay, more dots you can see, amount of oxygen dissolved in this solvent or water, it will increases, and it is directly proportional to weight, means pressure. So mole fraction of gas, we measure this concentration of gas in solvent water in terms of mole fraction. You can take in ppm, percentage weight by weight, normality, molarity, but mostly gas dissolved in liquid measure in mole fraction. So mole fraction of gas in solution is proportional to the partial pressure. So here mole fraction x1 is equal to mole of component solute upon total moles n1 plus n2. Okay, mole of solute means gas and mole of solvent means liquid. Partial pressure is directly proportional to mole fraction of solute added. P is equal to, if we remove this direct proportionality, then we put proportionality constant, that is KH. H stands for Henry constant. Okay, scientist Henry discovered this. How he discovered? If the graph is plotted against partial pressure against mole fraction. If you increase the partial fraction, means what? Pressure you increases one by one. Then mole fraction or solubility also increases. So you get the graph in increasing. Okay? Once mole fraction increases, partial pressure increases, or partial pressure increases, mole fraction. Because it is directly. You put the 3 point and find the slope. From this slope, we can find this Henry constant for a particular system of gas. So, partial pressure is equal to Henry constant into partial pressure is equal to, or it is directly proportional to mole fraction. And for a particular solution, Henry constant is there. For different gas and different temperature, different Henry constants are there. If temperatures change, then this KH value will change. Okay? From this, effect of temperature also plays important role. It depends upon which type of reaction, endothermic reaction or exothermic reaction. Again, if temperature is increases, then again vaporization will start. Okay? Mobility will increase. So dissolution of gas will be less. So increase in temperature, there is decrease in mole fraction of gas dissolved. At higher temperature, less gas will dissolve, and at lower temperature, more gas can be dissolved. So this is all about solubility of gas in liquid solvent. Okay, and you remember the formula Henry constant. Try to write this and try to solve the activity sum which is given in your book. Okay, thank you.